STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Clark Esty.
Good afternoon, STEM fans, and welcome to NASA STEM Stars. This is our 64th episode, and I am Taisha Batts, an education specialist with Langley Research Center, and I'm here with Clark Esty from Johnson Space Center. Clark, how are you doing today?
Hey, everyone, I'm doing well, thanks. How are you?
I'm good, Clark, and we are excited to have you here on our episode today. This is a special NASA STEM Stars episode where we actually got questions from organizations and camps throughout the country. So we're really excited that you're here with us and that we're able to share those questions with you. So, Clark, we're going to go ahead and get right on and started. So, tell me a little bit about your hobbies. I do know that you're an avid skier.
Yeah, so I grew up in a ski town in Utah, and skiing is one of my favorite pastimes. This photo here is actually from probably one of the best ski days I've had. So it snowed a lot the night before, and this is kind of the type of skiing conditions that I have come to live for. So as much as snow as possible. Um, Yeah, and it's always enjoyable. It's a very good pastime for me to get outside and stay active. And I try to do it as much as I can these days, which has become a little bit harder in Texas, but I still get back home every once in a while to ski.
Well, when I pick up skiing, I know who I need to call because I haven't skied yet. To actually, I mean, it's amazing, but I haven't actually got there. But I know that not only do you ski, but you also run a little bit as well. So, talk to us a little bit about that.
Yeah, so over the years, it was always kind of, just running a couple miles here and there to stay in shape. And as I kept doing it more and more, I was realizing I was enjoying it. Ran a half marathon, and then this photo is actually from the completion of my first and likely my only marathon, where my mom actually came out to support me as I crossed the finish line. And this was the Dallas Marathon at the end of 2019.
Oh, wow. So, how long was that marathon? How many miles did you do?
So it is 26.2.
Ooh, 26.2 is it's a lot.
Yeah, and yep, it was the first time I'd run that distance. A lot of training, they say, don't do it until the day, and I really don't know that I will ever want to do it again.
Well, I know you shared that special experience with your mom, and I think that you actually shared an experience with her that was her bucket list. So, talk to us a little bit about that.
Yeah, so my mom is, always enjoyed spending time in the outdoors as well, and she always actually wanted to raft the Grand Canyon. And so a couple years ago, she came to me and said, I got to do it now. Otherwise, I don't think I'm going to get around to doing it, and asked if I would be interested in doing it with her. Uh, and, enjoying the outdoors as much as I do, it was an obvious yes for me. And so this photo here is from about halfway through the trip. We actually rafted the entire canyon. And we were on a slightly motorized craft, so we did it in about a week. Um, but got to see a lot of kind of undisturbed area down at the bottom of the Grand Canyon there. So it was a really fun experience in general, but then it was special to be able to do it with my mom.
And that's great. And I've been to the Grand Canyon and it's awe inspiring. And I always thought about, actually rafting. And my son said no to that. So we never did. But that's an amazing experience. But you've also traveled a lot as well. So I know you went camping. So talk to us a little bit about your travels.
Yeah, so I've been very fortunate in having had the opportunity to go on a lot of backpacking trips kind of all over the world. I've done a couple multi-month trips, and this photo here is actually from Australia. A close friend and I rented a camper van for about 3 weeks and just spent the entire time driving up the eastern coast, or what they call the Gold Coast of Australia. And so this is from one of the places we stopped to camp overnight. You can see the chairs there. We were just reading and hanging out. And then on that same trip as well, we actually spent a couple months in some of the countries in southern Africa. And we were fortunate to go on a camping safari. And this photo here is from, we were in Botswana, and it's shortly after setting up our campsite. An older elephant decided to kind of meander through the camp here. And so, he's about maybe 50 or 100 feet away from there, looked at all of us and just kind of went, and kept meandering on. But it was a really cool experience to be able to be that close to a wild elephant.
Yeah, I can imagine. That's on my bucket list to actually go through a safari. So hopefully I'll be able to get that as well. And I know that you also had a wonderful experience hiking. So tell us about what you actually got to do, you and a friend.
Yeah, so as a part of it was earlier in that same trip, we actually went to Mount Kilimanjaro and did a multi-day trek to the summit of Kilimanjaro. And this photo is from us getting to the top right at sunrise. So the night before, you wake up at around 11:30 and you actually hike through the night. And you get right to the top as the sun's kind of beginning to crest over the mountain ranges. And so this is a photo from the brief amount of time we spent up at the top, and really celebrating and kind of the accomplishment of summiting the mountain before we headed back down. So it was a really rewarding experience. I would highly recommend it to anybody that likes doing that sort of activity, and is up for kind of the challenge of pushing yourself a little bit physically and mentally.
And I can imagine that was physically and mentally challenging, but it is always rewarding when you get to that end stage after you've done those things. So, Clark, we are doing a new segment at NASA STEM Stars, and it is called Lightning Round. So, I'm going to ask you some rapid fire questions, and you're going to give me some one word responses. So, are you ready, Clark?
Yeah, let's do it.
Time for NASA STEM Stars Lightning Round.
All right, let's put 30 seconds on that clock. Clark, city or country?
Country.
Early bird or night owl?
Early bird.
Talker or texter?
Talker.
Pen or pencil?
Pen.
Comedy or horror?
Comedy.
Pizza or pickles?
Ooh, pizza.
Introvert or extrovert?
Slight extrovert. Is that an
Multiple
answer?
choice or multiple choice or essay? That's where at the buzzer.
Ooh, multiple choice.
All right, Clark, congratulations. You got 8 questions on that. So you will be enshrined on our leaderboard. So I saw that you said that you were going to go with multiple choice or essay. I would think that you would go with essay. Why multiple choice?
I think that's the science in me. Kind of growing up and going through college, I always hated writing essays. And so in the sense of an academic sense, I would say multiple choice, which is why I kind of defaulted to that. But if it's more of a conversation or, describing something, an aspect of my life or some goals or something like that, I would probably say essay.
Okay. I would say multiple choice too. I think that's the science in me as well. So you brought up your childhood, and actually that's what we're going to talk about next. So tell us where you grew up and how that was, and if you had any brothers or sisters. So let's start with that.
Yeah, so I actually grew up in Park City, Utah. a small ski town outside of Salt Lake City. And I had two older sisters, so they were 8 and 10 years older than me. And so this is a photo of me kind of, as a young child with my two sisters in the fashionable ski gear at that particular time. But kind of exemplifies a lot of what growing up in Park City was like. You try to spend as much time as you can outside, and especially in the winters when you try to get out and ski as much as you can. And then this photo here is, me a little bit older, but kind of along those same lines, still in some very fashionable onesies at that particular time. But just, further exemplifies the amount of time that our family liked to spend outside skiing and really getting out to enjoy the light snow that happens to be in Utah.
And I know you also had a beautiful picture actually showing what it looks like at Park City. So I was a little jealous.
Yeah, so this is kind of a panorama of when we went up skiing. This was actually shortly before the resort opened one year, and just kind of exemplifies what the landscape looks like around there in the winter time. And so I was very fortunate to grow up so close to so many ski resorts and be able to take advantage of that. And it will always have a special place in my heart, even though, being in Houston now, I don't really get to ski as much as I used to.
Oh. And I can imagine being in Houston is a little different than being in Park City. But as you grew up and you went to high school, tell us what subjects did you like when you were in high school?
Yeah, so it was kind of early in high school that I really found my love for the sciences. And at that particular time, physics was kind of the most engaging subject for me. And so I elected to kind of pursue that and continue to follow that passion. But really, any of the science classes were what I enjoyed in high school. English was never my favorite subject, and to this day probably still kind of falls under that category. But I really just tried to take every science class I could just to get exposed and learn in many ways how the world works.
And so you talked about physics, and so with physics, as you moved on to college, I know that you had an internship at CERN. So talk a little bit about that. Did you enjoy that internship at CERN, and how long was it?
Yeah, so between my sophomore and junior year of college, I was very fortunate to be able to go out to CERN for a summer. The experiment I worked on looked particularly for a certain type of what we call a neutrino, so essentially a subatomic particle, and we really worked with some of the large-scale experiments to do some data extraction to try and prove out the models. So it was my first real opportunity to get outside of the classroom and kind of apply the physics principles I had, spent so many years learning to some real-life application. And I really loved being in Switzerland. I met some great people. I was there for about 12 weeks one summer, and I really hope to be able to go back one day to kind of relive a lot of those experiences.
And so after your experience with CERN, I know that you came to NASA, and I see that you have a photograph showing one of your visits that you got to go to another center.
Yeah, so this photo here is in front of the Vehicle Assembly Building, or what we call the VAB at Kennedy Space Center. I went there for a trip associated with work, essentially, and really tried to take advantage of my time there to get in front of a lot of the iconic landmarks associated with NASA. And so I was really fortunate to be able to kind of go and drive and be able to explore around the center a little bit. And so I really hope to be going back there one day in the near future, hopefully associated with some of the upcoming Artemis missions, to be able to explore a little bit more and hopefully watch one of the Artemis launches itself.
Yeah, that's my hope too. So we actually have a student question that kind of goes a little bit with the picture that you just showed. So we're going to ask Sean to ask his question.
What motor do you guys use to power the rocket ship to go fast enough to break through the atmosphere. Thank you.
So Sean was a little fast, but I think he was asking about the motor that you use that allows the rocket ship to break through the atmosphere.
Yeah, so that's a great question, and I'll speak to our Space Launch System, or our SLS rocket. And so the SLS actually uses multiple, and so we have our solid rocket motors, and so those essentially burn solid propellant, and you can think of it kind of as a model rocket uses the same type of propellant, but on a much larger scale. And then the center of the vehicle actually uses liquid propellants. And so we use liquid oxygen and liquid hydrogen. They're very efficient propellants. And then those actually go down through a turbo pump, and they come out through 4 RS-25, or 4 of the old Space Shuttle main engines. And it's the combination of those 4 engines fueled by liquid propellant, and then to 2 solid rocket boosters on the side that propel SLS up into the sky and into space.
Wow, it's amazing that all of that works together to get that and to propel it into space. And because you talked about the Artemis mission, we actually have another student, Bella, who has a question about the difference between a couple of missions. So let's hear Bella.
And I was wondering how the Artemis mission is going to be different from the Apollo mission.
Ooh, she had a wonderful question.
Yeah, so also a great question. So inherently, it's different in the sense that Apollo was all launched on one spacecraft. And so for Artemis, we have SLS launching the Orion vehicle with the crew, and then we'll have the Human Landing System, or HLS, launching separately. And so they'll have to rendezvous around the moon to go down to the surface. Also, one of the biggest differences is that with Artemis, we're actually going to the lunar South Pole instead of an equatorial landing site, or a landing site near the center of the moon. And so it'll offer a very different landscape and offer us the ability to really learn some different scientific components of both the history of the moon, as well as understanding how we can live and survive on another body as we start to go for longer and longer durations.
That's a wonderful explanation of the difference between the two, and that she really understood to ask you that question, that there is a difference between the two. And you mentioned HLS, and I know that a lot of people think that engineers at NASA are just launching and building and doing all of these things, but there are some times where we do have to do presentations and speak to a group. So talk to us a little bit about that.
Yeah, absolutely. So communication is a really key aspect of, being an engineer in whatever you do. And so this photo here is actually at the end of one of our design analysis cycles. And we were getting ready to kick off our next cycle. And this was an opportunity where we all came together to present findings from a lot of the various work that had gone on to get up to that point. And so this was earlier in the HLS lifetime, or I should say as the program itself was getting formed. But just goes to exemplify, right, that communication is always a key aspect of whatever type of engineering or work you do. And being able to concisely and clearly communicate, especially when you're talking about very complex technical subjects, is very important and will be a part of your day-to-day job as you move forward.
And that's important for us to understand as well, and the fact that we talk to the community so much, just to be able to break down that information so that they know exactly what's going on. But also at NASA, you do get to see a few launches. So talk to us about one of the launches that you were able to at least be there for.
Yeah, so earlier in my career, I was very fortunate to work one of the Antares vehicle launches. And so Antares resupplies the International Space Station. And this launch took place out of Wallops Flight Facility on the eastern shore of It's actually in Virginia, but just around the Virginia-Maryland border. And so this photo was taken, a couple days before launch, when we were able to go down to the launch site and walk around and kind of make sure everything was in place and ready for launch a couple days later. But it was a really exciting opportunity to, kind of see a lot of the hard work come to fruition.
And so that was amazing. I've been to Wallops a couple of times, so it's amazing to actually get to see a launch that's there. And you also got to experience with the astronauts experience in the Orion mock-up. So talk to us about what you were able to do in that mock-up.
Yeah, absolutely. So this here is a mock-up of Orion that's at in one of the buildings at Johnson Space Center. And I was fortunate enough to be a part of some timeline studies that they were doing. And so they were trying to get an understanding of how long it takes to perform certain tasks. And they tried to do a lot of that work and flesh out their understanding before they begin to get the astronaut crew themselves involved. And so this was one of the earlier studies where essentially just workers on the center were participating in it. And it was about a half a day where we got to kind of go through getting ready to, or some of the procedures to get ready to come back to Earth. So right before you re-enter into Earth's atmosphere.
And so that actually leads us to one of our student questions. So Daniela had a question for you about Artemis.
What are the characteristics of the people you want to recruit for the Artemis mission? Thank you.
She had a great question about the recruitment of the characteristics that we're recruiting for the Artemis mission.
Yeah, also a great question. So, I mean, honestly, we need people that do anything. So obviously we need to recruit for the astronaut corps to have people that fly on them, but we need a bunch of engineers to help build it. We need people to help integrate the image together. We need people that fall in business to help us figure out how we can buy all the pieces we need and figure out kind of the supply chain of how do we get the right items to the right area at the right time. We also need people that focus on communication and public outreach, right? We are a federally funded program, so the public money does get used to help fly these missions. And so it's our job to help convey that value to the general public as well. So really any specialty or for any specialty, there is a place at NASA for you. It doesn't have to just be in necessarily the STEM field, although that is a big majority of the employees that we do hire.
And it's great that you talked about that we need all types of people, because I think a lot of people, like you said, only really think about the STEM, but don't think about, the business that's there and maybe those people who communicate and those things and the marketing and all of those things that take place. And so we actually have another student who had a question about what we do if there is a problem. So let's listen to Selvy's question.
My question is, what would you do if someone from the crew had a serious injury in space?
Yeah, also a great question. So a lot of that kind of depends on what the injury is. So I'll assume, for the sake that it's a serious enough injury that you would want to get them home as quickly as possible. And so what the exact action would be would depend on where you are in the mission. But a lot of our mission planning work that occurs before flying a mission really understands the trade space of where you can perform an abort and how we would get one of the crew members home as quickly as possible. So we really do try to think of any potential situation where something could go wrong and how to mitigate or solve that particular issue. So in that case, we would really want to get them home as quick as we can so that we can leverage taking care of them here on Earth.
And that's great that you talked about that we do have that mitigation or that problem solving that takes place. And so, also in your career, you talked about that you get to travel some, and I know that you've been to Kennedy Space Center a couple of times. But talk to us about this one photo that you have while you're standing at KSC.
Yeah, so this is in the Space Shuttle processing facility. And so this is one of the huge clean rooms that they actually use to prep a lot of the ISS modules before they went up to space. And so, when we were there, we were taking a look at a couple of some of the potential habitat modules for the upcoming Gateway. And it was just a really cool opportunity to, walk through a place that has so much history, but really begin to further understand the magnitude and scale of these places and what it takes to really fly a successful space program.
And so you talk about, flying successfully, and we have another student question who had a question about flying. So let's look at Coleman's question.
Do you ever get worried that space rocks or meteorites will crash into your spaceships?
Yeah, it's a great question, Coleman. So we do a lot of statistical studies to understand what the likelihood is of getting hit by one of those. So we're a little less concerned as we get out towards cislunar space. It's less of a probability than it is in low Earth orbit, so kind of where the space station is. But we do have the ability to detect and perform some maneuvers to avoid some collisions. But then also we have additional procedures in place should a small rock puncture a hole in one of the pressure vehicles, that we actually have the ability to provide enough pressure control so that the crew can get into their suits safely and we can begin working to get them back home. So we do account for that, but once it falls below a certain probability, we kind of change the approach to how we solve the problem.
And that's wonderful that, you can actually look at those problems and try to come up with solutions, just like you did when you talked about the mitigation. And so you kind of talked about, traveling at NASA and looking at those problem solving. And one of the other big things that we do at NASA is outreach. So talk to us a little bit about that.
Yeah, so, I believe outreach is kind of a key piece of what we do. I mean, I love my job and I love, trying to excite others to pursue their passions. And so this photo here is from an event that we did at Rice University, so local university in Houston. And we actually were fortunate in that the former Administrator Bridenstine, came to Rice because it's his alma mater to also participate in that outreach event. And so it's just, meant to continue to get out there, talk with people about what we do, and explain how we really do have there is a place and an opportunity for everyone out there. And we do really want to excite people. It's a really exciting time to be in the space industry. And we really just want to convince people that, NASA is kind of the place to be. And we really do want you all to come work at NASA.
And we actually have some students who are thinking ahead, getting ready for those roles that are there. So we have another student question, and this is from Meredith.
When astronauts are sent into space, how long until their bodies are affected by the zero gravity environment? And when they are back on Earth, how long does it take for them to recover?
Yeah, so you essentially feel the effects of zero gravity right when you get to space. A lot of that is tied with your inner ear and your body rebalancing to the new environment. But essentially the fluids in your body do rebalance almost immediately after getting into zero gravity. Now, coming back to Earth, the answer is a little bit variable. So a huge factor in that is how long you actually spend in space. So if you're doing a shorter mission and come back, your recovery could be a day, not long at all. But for some of those longer missions, some of those missions that can be up to a year, your body readjusting and your recovery can take weeks or even months before it kind of readjusts and gets back to closer to a normal state.
Wow, it's amazing how our bodies just function in space and how we're able to come back, and it might take a little time. But we do have another student who had a question about the moon. So can we listen to Preston's question?
Are you planning to build a permanent base on the moon that is constantly occupied like the ISS? If you are, what are you planning to use it for?
Yeah, so currently we're not planning to build a permanently inhabited base on the moon. So we're working towards building up our capability for longer and longer surface stays. But really, a huge part of the goal is to get ready for missions to Mars. And so we want to get better at, improving our operational procedures as well as testing and proving out a lot of the hardware. But we're really doing it with the end goal of getting to Mars. And so the goal as it stands today is not a permanent habitat on the moon, but that's not to say that it might not be in the future, especially once we have really made that big jump and also started sending humans to Mars.
And so it's amazing how students are thinking about, permanent bases on Mars and just all of these complex questions that they have. They're getting ready for NASA. And so we have our last student question from I'm going to be at NASA soon. So let's play Jack's question.
How to become an astronaut?
Yeah, so right, I think that's the answer to that is something a lot of people are after. But I think the key pieces are make sure you work hard, study hard, excel at what you do. A huge part of that is pursuing your interests, right? And kind of diversifying and showing that you really have the ability to critically think and problem solve. But also that you are capable of it from a physical standpoint, so from athletics, and a huge part of that is tied to some of the sports that people choose to do as well. So really just, making sure you work hard, you have dedication, and that, you keep the end goal in mind as you progress through.
And so that is great. Great advice for all of the students. And to get them ready to start making those problem solving skills, we actually have a call of action to our students. So students, we are going to pack for the moon. So the activity that we have for you is priority packing, and we want to see exactly how you pack for the moon. So don't forget to share that at us at #NextGenSTEM. And we can't wait to see you again next week, where we're going to have next week Dana Bowles. She'll be here next Wednesday at 2 o'clock, July the 21st. So we can't wait to see you all back, and don't forget to subscribe. So before we go, we would like to have Clark give us some last advice that he has to the students. Is there anything you'd like to tell them, Clark?
Yeah, I think, some final words that I would leave you with are, really just pursue your passion and be open to the adventures that will come your way. I think working hard is something that everyone kind of states in as important, but pursue what you're really interested in. And lastly, if you don't know something, that's totally fine. A perfectly good answer is, I do not know the answer, but I'll go and figure it out. And so I would kind of leave you with those two to, use as you work through. And I'm really excited to see where all of you end up in your careers. And I may be a little bit biased, but I definitely hope to see you around at NASA.
That's okay to be biased. And Clark, we thank you for being with us today. And we also thank all of those camps and organizations who sent in questions and the students' questions. Thank you again. So have a great day, STEM fans.
Thank you.